Hello, welcome to Sigma Tech Consult Limited. Today we'll learn mathematics, and in mathematics we are going to look at similar shapes. Okay, so before we begin, let's look at the objective of this class. Our learning objective is that students, you should be able to define similar shapes and solve questions on similar shapes when you see them in your exam or anywhere, okay? So by way of definition, similar shapes are objects that have the same shape but not necessarily the same size. They have the same shape, okay, but they don't necessarily have the same size. They are called similar shapes. They may have the same size, but then we can have that particular object of different sizes, yet they are similar shapes because they have the same kind of shape, okay? Now, they are considered similar. Why will we call them similar? They are considered similar if the corresponding angles are equal and the corresponding size are in proportion. That is, they have the same ratio, okay? So that is how we know that an object or two objects are similar. For instance, look at the board. Let me show you something. Let's say this is a triangle, and this is another triangle. Let's say this is another of this triangle drawn here. Okay? All right. Or let me even say, let's look at an isosceles triangle. Okay? Let's look at this type of triangle, and let's also have something like this. All right? Now, let's say at this point, we say this is the angle we are considering, and here, this is the angle we are considering. Okay? Now, we want to see the similarity between these two shapes. Now, let's say this is our angle A, B, C, and this is our point A, B, C. Or let's even say, yes, let's say A, B, and also C. Now, you know we have said that, yes, similar shapes are objects that have the same shape. These two objects, they have the same shape. But what makes them similar does not end with them having the same shape. Okay? Where we begin to consider them similar. And okay, first of all, in the first definition, we also say that they may not necessarily be of the same size. So they are not of the same size and they have the same shape. Do you understand the point? But that does not make them similar, actually. What makes them similar, where we consider that an object is similar, is if their corresponding angles are equal. Now, look at the angle A. Angle A, okay? And look at our angle A here. Let's say our angle A is giving just 1, okay? Let's say this place is giving 1, this place is giving 1, 2, 3. This is giving 1, 2, 3. Do you understand the point? Now, this shape, if we consider angle A here and angle A here, angle A here has just one double line or double arc that is telling us what the size of that angle is. Here is just one. So this is not a similar shape. Do you understand? Even if they have similar shape or their shapes are similar, it's not considered in what we refer to as similar shape. Do you understand the point? So if you look at B, here B has 1 and B here has 2. Okay? The only angle that is similar between this thing is this side and this side. Do you understand the point now? Okay. So let's also look at this now, that we have something like this. And we have something like this too. And here, they gave here to be this. Why? They gave here to be this. 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 they gave it to be this. This shape, they are not similar. In the sense that, if you see, in terms of, we also said that they are considered similar if the corresponding angles are equal and the corresponding sides are in proportion. So if you look at this now, this side, let's say this is side AB, is not in proportion to side AB in this other angle. It means that this side is not in the same ratio with this side. Do you understand? This side is not in the same ratio with this side. This side is not in the same ratio with this side. So how do we now understand the concept of similar shapes? How we understand this concept is, let's assume this that we have here. We have this shape here, and we have this shape also here. And here, they gave us this place, this and this place, this and this. This place, let's say they gave us here like this, and they gave us here like this, they gave us here like this, gave us here like this, gave us here like this, and like this. We can say that these shapes, they are the same, they are similar shapes. Do you understand? We can even have something like this. Okay? And we have, okay, if you look at this angle, they are not looking like the same thing. But if we have here, let's say this is this, this is this, then here, let's say here we have this, here we have this. Do you understand the point now? This is a similar shape. This is an example of a similar shape. This side is proportionate to this side. This angle is proportional to this side. So if this is this angle, it means this is a right angle triangle. What that simply means is that every other thing that we have here, they must equal to 90. Do you understand the point now? This is the hypotenuse. This is the hypotenuse of this particular side. Did you understand the point now? Okay. And let's say this and this could be this. All right. It is at this point that we say that they are similar shapes. Okay. So these similar shapes apply to both plane shapes and solid shapes. So we can see these things in plane shapes that are similar. We can see it in solid shapes that are similar. Hope you understand. You can still remember what plane shapes are. They have 2 dimensions, okay? While solid shape 3 dimensions, okay? All right. So let's look at. We'll have to solve some problems. Look at some problems using the Examguide learning app on similar shapes, okay? Okay. So they say use the similar triangles below. So this is similar triangle. Why are they similar? Look at the triangle very well. Just look at the board. We have, this is triangle TSU. And another triangle VXW. Do you understand? Now, if you see this angle S has 2 strokes, angle W has 2 strokes, it means that they have corresponding angles. Remember, one of the things we look out for to say that 2 shapes are similar is that they must have a corresponding angle. Their angles must be corresponding and their side must be proportional to each other. Do you understand the point? So if this place is the same angle with this, it means this is a similar triangle. Is that okay now? Okay, so they're asking us to calculate ST. Okay, they are asking to calculate ST. That is this angle, ST. Is that okay now? ST. So let's look at that. They say we should use it to answer question 41 and 42. So we'll also use this to answer another question maybe along the line. So let's look at the first one. So, see what we're going to do. We're going to pick. So now, look at this. Let me draw that angle here. We have this, this, and this. Okay, and they say it is STU. Okay, this S is double 6 cm. 3 cm. Okay, we have 1 here, right? Then in the other triangle, we have this. This is how the triangle looks like. And we have it this way. So the first, in this place, they said it is V, 1 stroke, right? X is here. Then W is here. So in our W is equal to this angle S. Okay, XW is 12 cm, right? XV, 8 cm. This place is 8 cm. Now the question is that we should calculate ST. Find ST. That's what they're asking us to find. Solution. ST. So they're asking us to find this side, right? So to find this angle, we must apply our knowledge of ratio, proportion, ratio. Do you understand the point? So we're going to take the ratio of the side that is corresponding to ST in this side to the ratio of any other side that we think that is corresponding to another ratio here. Now look at this now. If you look at ST begins from where you have this double line to where there is no angle given, which is this place. Now look at it here. It means that in this angle, what corresponds to this side, look at this now. What corresponds to this ST, remember our point of reference is where we have these two arcs. Okay, where we have angle S, these two arcs, to where the angle was not given or the angle was not labeled. Do you understand the point? Okay, now look at this angle now. What is corresponding to this side is here, from this place that is, from this W to X. But because this side is labeled, this side is here, this side is here, this side is here. Do you understand? So ST is in the ratio of WX. Do you get that? So we say that ST is to ratio what? WX. And it's equal to what? So we just apply our knowledge of ratio. So we can also choose another side here that correspond. So there must be correspondence between these two angles or these two shapes that you're given, between the two shapes that you're given. So let's look at this now. Let's look at another. We have, from where we have one angle given to where we have no angle. Let's see if it is like that here too. One angle given to no angle. So it is not given in this side. So we cannot use that. And let's look at the other side. Where we have double angle to one angle. Let's look. Double angle to one angle. So that is what? Double angle to one angle. The reason why we will not use one angle to no angle is because in this other side, okay, there is nothing in one angle to no angle. Because if we do that, we are now looking for two things. They ask us to look for ST, so let's look for values so that it is only one variable that we are looking for. Do you understand? So we are going to do double angle, one like this double and single, this side, that is SU, that is SU, line SU is to, in this side now, we said double to single. So we have here double to single, that is WV, that's line WV. Is that correct? That is it. So this means that ST all over WX is equal to SU all over WV. Right? That is what it is. So what is our ST? We don't know, which is what we are looking for. Over WX is what? WX is 12 cm. So this is 12 cm. Remember what we did there, we just applied our knowledge of ratio. We have ratio in this channel. Go to that topic and know what we did here. We did a lot of things in ratio. Okay? Now we go to equal to SU in the other shape. SU is 6 cm. Go to 6 cm divided by WV. WV is 8 cm. 8 cm. All right? So we cross multiply. So this will be line ST, okay, times 8 cm is equal to 6 cm times 12 cm. All right? So what that will simply mean is that ST, line ST will now be equal to 6 cm times 12 cm all over 8 cm. Do you get that now? Okay. So this cm, we remove this cm. Okay. 8 here is 2 into 8 is 4. 2 into 12 is 6. 2 into 4 is 2. 2 into 6 is 3. 2 into itself is 1. 2 into 6 is 3. 3 times 3, 9. So it means that, therefore, our ST, line ST is equal to what? 9 cm. Okay? 9 cm. So our ST, as they asked us to find, is equal to 9 cm, which is option C. All right? We go to the next one. Now, let me look for the 42 of this. They say we should use it to calculate 41 and 42. Okay. So let's look at the next part of the. Remember, they say we should use it to calculate 41 and 42 in the question there. So let's look at the other part of it. They say calculate XV. So XV is this particular shape. XV. Okay. Remember, ST is now what? 9 cm. Remember? All right. So it means we are now looking for line XV. Right? So line XV will be what? Look at XV. So it will mean XV is proportional to what? Which line is XV proportional to? That is from where we have one single arc to nothing, right? That is from one single arc to nothing, that is 3 cm. Is proportional to UT. UT equals to, we can choose any particular side. Let's choose this side, or any particular, we can decide to choose this side and this side. Do you understand the point? That any side you want to choose. If you want to choose this side, it means you will do double to nothing, that is double to nothing. Do you understand? Or you do double to single, double to single. So anyone you wish to use, you can use any of them. But since we've done this one, let's do this particular one that we just got now, right? So what that simply means is that let's do double to nothing, right? Double to nothing. So it will be, they're asking us to do double to nothing, that is XW. XW is to double to nothing, double is to ST. ST. Right? So this will now be XV is to, what is our UT? XV is to UT is 3 cm is equal to, what is our XW? XW is 12 cm is to double to nothing is to 9 cm, right? Good. So this means XV all over 3 cm is equal to 9 cm, sorry, 12 cm all over 9 cm. Cm can remove cm, okay? So we have cross multiply, we have XV times 9 is equal to 3 cm times 12. Is that okay now? So this will now mean xv to be equal to 3 cm times 12 all over 9. Is that okay? Okay. So 3 into itself is 1. 3 into 9 is 3. 3 into itself is 1. 3 into 12 is 4. So we say that xv is equal to 4 cm. Right? That is the answer for xv, which is option B, 4 cm. All right? So let's look at this. Say we should calculate DC in the figure below. DC. So this is a right angle triangle that has been given to us. Oh, yeah. Okay, let's assume it's a right angle triangle, though angle was not given, so we can't really say for sure if it is right angle triangle. Okay? So that is, let's draw the shape here so that we can have enough space to solve. This is the first triangle, PQR, 15 cm, 15 cm, 9 cm, 1, okay, Y here, this double, and this is our C, this is our B, this is our 6 cm, and this is our D, having 1 angle. So they're asking us to find DC. Find DC. That is this DC. Is that okay? Simple. What is the ratio of DC and what is proportional to it? So we say DC, remember DC is proportional to what? DC in this shape. DC in this shape, all right, is proportional to what side in this shape? Remember, we have our DC where we have 2 strokes and 1 stroke. 2 stroke, 1 stroke. So it's proportional to PQ. PQ. So it is now equal to, we choose any particular side we know we can get. So look at in this shape, double knotting is 6 cm, that is BC is proportional to, let's go to double knotting in this side, double knotting. So it's proportional to QR. QR. So that means that DC is now proportional, is now in the ratio of PQ. PQ is 15 cm. Is equal to, what is our BC, 6 cm, is in the ratio of QR. QR is 9 cm. You see that? So what that means is that DC all over 15 cm is equal to 6 cm all over 9 cm. Is that correct? So this removes this. So it means that our DC, by cross multiplication, our DC will be multiplied by 9 cm equal to 15 cm times 6 cm. Do you understand? 15 cm times 6 cm. So it means that our DC will now be equal to 15 cm times 6 cm all over 9 cm. This cm can remove this particular cm, right? 3 in 9 is what? 3. 3 in 6 is 2. 3 in itself is 1. 3 in 15 is 5. 5 times 2 is 10. So we say, therefore, DC is equal to 10 cm. DC is equal to 10 centimeter. Is that okay? That is what the value of that will be. Okay? Okay, let's look at this. If the area of two similar shapes is 49:121, determine their linear scale factor. What is their linear scale factor? So their area of two similar shapes is 49:121. So area factor, area scale factor is 49:121. So they are asking us of linear scale factor. Linear scale factor of this. Okay? So linear scale factor of an area scale factor is just the square root of the area scale factor. It will give us the linear scale factor. Did you understand the point now? Let's say if let the linear factor of 49 be A, okay, and that of 121 be B, okay. So this means that A is to B is equal to 49 is to what? 121. But then to find the linear scale of this, we'll have to find the square of this. Do you understand the point now? So what that simply means is that A over B square is equal to, we squared it both sides, 49 all over 121 all over 121 all over 121. So that is actually what this means, because the square of this is what gives us this. Do you understand the point now? So what do we do to now get this thing? We have to square root both sides. So if we square root both sides, we'll have square of A over B is equal to square of 49 all over 121. Okay? So square will cancel square root. So it will now be A over B to be equal to root of 49 and square root of 121. Okay, so A over B is equal to root of 49 is 7, while that of 121 is 11. So the scale factor of this area factor, the linear scale factor, is 7:11. Okay, 7:11. All right, and that is option C, 7:11. All right. So let's look at option. Let's look at the next question. They say the radii of two similar beakers are 3 cm and 4 cm, and they said if the volume of the smaller one is 27 cm cube, find the volume of the bigger one. All right. So let's. Okay. So like we said, the concept of similar shape is not just for plane shapes, so it's also for solid shape. Like a beaker is a solid shape. Okay, so let's look at that question again. So that question says the radii of two similar shapes. So the small one and big. So this small one is 3 cm, second one is 4 cm. And the area of small and the volume of small, they said is 27 cm cube, while volume of big, they didn't give it to us. Okay, so let's just call it anything like X or B, bigger one. Okay, So they say find the volume of the bigger one. So what this means is that 3 cm is to 4 cm is equal to 27 cm cube is to, let's say, B, that's the bigger one, okay? Okay, so this is what this actually means. So what that means is that if we have 3 cm and 4 cm here is to 27 cm cube, and what will be here? Is that okay now? So it means that to find out of the bigger one, the smaller one gave us 27, which is the cube of 3. That is 3 times 3. Okay? Times 3. Do you get that point now? Why? What we'll have to do is to find the cube root of these particular ones that we have here. So to find the cube root of this one is going to give us 3. Cube root of 27 is 3. So cube root of what? Cube root of what will give us 4? That is what our question will be. So 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Now if we have cube root of 4 times 4 times 4. 4 times 4 is 16. 16 times 4. 4 times 6 give us 24. So write down 4. Carry 2. 4 times 1 is 2. Is 4 plus 2 is 6. So is 64 that we are supposed to have here. How we simply got this now? How do we do that? Three cube, 4 cube. Okay, so this gives us 27 cm cube, and here 4 cube, this gives us 64 cm cube. Is that okay now? So it means that the volume of the bigger volume is going to give us 64 cm cube. All right. Okay, this is another similar triangle that you can try out. I think this is just similar to what we did, just a few examples away from here. I think something around here. Okay, so you can try out this, check it out. You can solve it and give your answer in the comment section. Let's look at for other questions that may not be very familiar with you. Okay, let's look at this now. Let's look at this. Okay. Find RS in the figure below. So we should find, okay, let's look at the triangle. This is the triangle. In fact, let's okay, so let's have the triangle this way. So this triangle has another line here, and this line is parallel to this line, right? So this is FRE. This is FRE SG. SG. Okay? Now, this point is 8 cm. This place is 4 cm. This place is, let's get that, 6 cm. Okay? So, they're asking us to find RS. Find RS. Now, look at this. Look at this angle. They did not give us two shapes, but they gave us a shape inside of that shape, we can get two shapes out of it in one. Look at the first one. This is the main angle that we can see, EFG. And we also have ERS. Can you see that now? So we can bring out two angles from there. The first one is EFG, the bigger triangle there. That is this. So the first triangle is EFG. Right? Then in that EFG, we have here as 8 cm in this triangle. Okay? Now, listen, they say this side, they mark this side for us. The next angle that we have there is this small one. Look at this one. So this one is another angle. Now, another angle we have there is this angle, ERS, and they also, so this line, there is a proportionality between this RS and FG. Is that okay now? Now, when they gave us, they said that from this place, see this angle now, from this E to here is 6 cm. Then from S to this place is 4 cm. It means that between E to G is how many cm altogether? 10 cm. So we have here 10 cm. That is how 4 plus 6. 4 plus 6. That is between this place to this place. 6 cm plus 4 cm, that is 10 cm. Why for ERS is just 6 cm? Here is 6 cm. Do you see the difference now? So at this point, we can solve. They say RS. It means that line RS, is that what they asked us to solve? RS, yes. More is in which ratio to this? Is in ratio FG. So it is FG. Okay? Which is equal to, all right, this side is given and this side is given. So ES is to EG. All right? So it means that our RS, okay, is to ratio, our FG is what? 8 cm is equal to ES. ES is 6 cm is to ratio EG. ES, then EG. EG is 10 cm. 10 cm. Right? So this means RS all over 8 cm is equal to 6 cm all over 10 cm. Right? This removes this. All right? So we have it to be, if we cross multiply this, this will be 10 times RS is equal to 8 cm times 6. Is that okay? So it means that our RS, if we make it to be the subject, our RS will now be equal to 8 times 8 cm rather, 8 cm times 6 all over 10. Is that okay? 2 in 10 is 5. 2 in 6 is 2 in 6 is 3. Is that okay now? Okay. So what we now have there is 8 times 3 all over 5. All right? 8 times 3 gives us 24 divided by 5. Okay, so let's look for, let's finish that here. Okay, so we have RS to be equal to 24 divided by 5. So if we do that, that will mean 24 divided by 5 will go 4 places. There will be a remainder of 4 over 5. That is 4 whole number, 4 over 5 cm. 4 whole number, 4 over 5 cm. That is option A as the correct option. So you have a couple of things that you can do with similar shapes, especially when it comes to similar triangles and any other kind of shapes that you'll be asked to do. Okay, so just keep practicing on these similar shapes and get prepared for your exam. I will meet you again in subsequent time. Bye for now.